Okay, here on example 2, we're going to try to find some trigonometric ratios. So they give us a triangle where they've labeled one corner angle C, one side angle A, or sorry, side A, which means that this guy would be angle A, this guy would be side C, side B, and angle B. Okay, that's kind of our common way that we do this. We always have the side and the angle across from it labeled with the same letter. Typically, the angle itself is the capital letter. Okay, so they say the cosine of angle A. Okay, cosine, so ka toa. So your cosine should be your adjacent divided by your hypotenuse. Your is 9 over 13. So your adjacent side, this B, should be 9. And your hypotenuse should be 13. Okay, those numbers check out. Hypotenuse should be bigger than the adjacent side. Use Pythagorean Theorem to find A. Okay, well, anytime with a right triangle, we should always be able to find the third side if we have two of them. So we're going to have A squared plus 9 squared equals 13 squared. Okay, Pythagorean Theorem is probably one of the most important things to know in geometry because it basically describes relationships between the sides in the most basic shape that we have, the triangle, right? If we're in 2 dimensions and we just pick 3 random points, we make a triangle. Okay, that kind of defines it as what I would call the simplest 2-dimensional shape. And if we cut that triangle into 2 pieces, we can always cut it into 2 right triangles. So really the right triangle um, is a shape that's really, really fundamental. It's really important to know the connections between the features of that shape, and that connection is our a squared plus b squared equals c squared equation. 13 squared, I think it's 169, but let me double check. Yes. Okay, so then we can remove 81 from both sides, getting us down to 88. And then we will take the square root of both sides because we don't want a squared, we just want a. So we will get plus or minus the square root of 88. They're simplifying that down to 2 root 22. Okay, so that's fine. Whenever we have radicals, remember we can break those radicals apart. We can hunt down any perfect squares that we see as factors, and then we can simplify those perfect squares. Okay, so our a is plus or minus 2 root 22. So we can add that to our picture up top. And since we are dealing with like a physical object with a physical size, I'm not going to say plus or minus because this is, all these lengths are positive values. So we're just going to say positive 2 root 22. Okay, so for the following ones, they want us to figure out, each of these different, these 6 different trigonometric ratios, the outputs of these trigonometry functions applied to angle A. So for sine, it would be opposite over hypotenuse. So that'd be opposite would be, this guy over the hypotenuse. For cosine, CAH would be adjacent over hypotenuse. So 9 over 13 looks good. Tangent would be opposite over adjacent. So it'd be 2 root 22 over 9. Cosecant is our flipped over sine. So it's just this one upside down, 13 over 2 root 22. They change it to this 13 root 22 over 44. That's called rationalizing the denominator. Typically, it's kind of a convention that we don't leave radicals on the bottom of fractions. So to get rid of that, we'd multiply by like root 22 over root 22. A different way of multiplying by 1, and that'll get rid of the radical in the denominator. For secant, we're just going to want our opposite of cosine, right? It's going to be our hypotenuse over adjacent, so it'll be 13 over 9. And for cotangent, it'll be the flipped over version here. So it'll be adjacent over opposite, 9 over 2 root 22. Okay, and that's all that it would take to figure out those 6 different trigonometric ratios for this particular shape.